This is an electronics retrofit, order number 47237. This is an overview of what I've done. I fastened the Mach3 USB controller on this piece. There was another controller that was there. This is a controller that was used it's actually around 1997. Had its own microcontroller and push buttons for probably the axis movement and different features. This one plugs directly into the computer, USB. I wanted to make sure that this is fastened down, and the 24-volt power supply that he had also fastened down, and I'm using this plate to do it. The entire box was cleaned thoroughly. I really needed to do that to be able to really understand the color of the wires. At the state that it was in, the wires actually all looked gray because of the amount of dust that was in here. Not a big problem bringing it in with this kind of dust. I don't mind actually cleaning it, but this is the kind of work that I do, that I want to have this kind of quality for my customers when they bring in any kind of condition. I want to make sure that I get the electronics back to them in a much better condition than it was in. A lot of these wires, the power wires, were held together with wire nuts, and I did away with all of the wire nuts. Let me turn this around. So all of these wires here were wire nutted to much longer wires, and it really kind of made it a little bit more hard to understand what was going on here. This is a relay. It's a 12-volt relay. What this does is it takes a 12-volt signal or a 12-volt power, DC power, and once that is engaged, or it has 12 volts, these two terminals will connect. These two on this side and these two on this side. So this is the neutral. This is the power coming in. This is the power coming in here. And when it's turned on, the power goes to this side, or connects these two together. So power goes to this point here. And once there's 12 volts, these two will connect, and these two will connect. So the neutrals will connect and the lives will connect. If I had it plugged into this one, these two, then these would be normally closed. So that means they would connect when it's off, and then when you turn it on, it would disconnect when there's 12 volts powered here. So this is just a standard relay. There's really no need for it, but I kept it in there because the customer had it in there, and it doesn't really matter if it's I guess used. He may want to use it for another purpose later on. This is a 12-volt power supply, so I'm taking the 12 volts here to engage the relay. The 12 volts can be used for something else, which I am using it for the fan over here. The fan runs on 12 volts, so I connected that along with the 12 volts on the relay to power the fan. Fan works fine. The power comes in here. The ground is grounded to the chassis. This one is also grounded to the chassis. The 12 volts comes directly to, I'm sorry, this is a 24 volt power supply, which is mainly to power the Mach3 USB controller. And that is connected to also this side of the switch. So when it's on, this directly gets power, no matter if this relay is on or not. So this will want to have power to provide power to the controller before it gets power from the relay. Let's see. The customer had the output of this to one of the relays. I can't remember which one at this point, but there's really no need for that. The output is really would be good for using the output for the tool. The problem here is that these are 12-volt relays, and the outputs here will provide a 12 volt power rather than a 24 volt power rather than a 12 volt. So I'm going to contact the customer to see what he wants to do about that. I can add a relay if he wants me to add a relay. Otherwise, he can plug his tool in directly to the 110 or 220 power, since I noticed that he's just using a standard router. So that can just be plugged in if he wants to run right now. But later on, if he wants to connect this to another relay, he can do that. But I'll talk to him just to make sure. All of the drivers have been wired correctly to the Mach3 USB controller. These are drivers that take in, actually these are 3 DC power supplies that put out about 70, a little bit more than 70 volts of power. So each one of these drivers is receiving 70 volts of DC power. The signals are step, direction. This is actually ground, it's not connected. Step, direction, 5 volts, and enable. And it was actually kind of hard to find the data sheet for this, but I was able to find it. So what I did is I connected 5 volts on each one of these to the 5 volts of the Mach3 USB. Let me turn this around. So the 5 volts is here, and so all 3 drivers are connected to the 5 volts here. So that means that you have to toggle it in a different way, toggle the step active low in a different way in Mach3 to get it to work. Generally, they use ground as the common, and then the step and direction will be active high. So this was done in the reverse. Let's see. Emergency stop is connected to input number 1. I do not know, this particular cable here is for the limit switches, but the customer needs to tell me what colors or how the limit switches are connected, because if they're connected in series, they're going to have to be reconfigured or rewired. If they're connected in parallel, they can be connected here, but I need to know which color wire, so I'm going to contact the customer on that. I wasn't able to test these motor cables, but I am going to show the testing of each driver with a motor that I have in stock here. I think that is it. So the next videos you're gonna see is the testing for each driver for the motors. Order number 47237. This is a test for the X-axis motor spinning. I heard the motor engage. All the clicks that you hear are relays. Actually, I have this relay connected to the switch, so when the switch goes on, this 12 volt power supply engages that relay. Alright, so I'm going to go ahead and do the left and right arrow keys, so we should see the spinning for the X-axis. Okay, that's good. This particular motor is I don't think it's properly sized for this particular driver. That's why you saw the stall, but I have different configurations, and actually let me go ahead and slow that down. For the motor tuning, the Y-axis didn't have a stall, and that was going at 300 IPM at 2,000 steps per. Let's do that to the X as well, 2,000 steps per unit. We'll take it from 1,000 to 300. Save axis settings. Okay. Should go into reset mode. It didn't, but that's alright. Okay, good. So that works. The motor is still cool. That means it's not going over the current that the motor is suitable for. Okay, that concludes the X-axis motor test. Always turn the electronics off before you unplug anything from the drivers, especially the higher power side of the driver, which is on this side. Order number 47237, motor test, Y-axis. Got the blinking here. If I do, I'm resetting. If I move like the X-axis, I don't have it connected to the X-axis right now, but you'll see it spinning. Okay. The e-stop was on, so we know that works. So I had to press reset to make sure that I get out of the reset mode, since the e-stop was engaged. So when I press the left and right, you'll see that the button or the LED flashes. And if I go up and down, which is the Y-axis, I do have a motor connected to the Y-axis that should spin. And it spins in both directions. So the Y-axis passes. Order number 47237. This is a test for the Z-axis motor spinning to make sure the motor works with the configuration that has been wired up. So I'm going to turn this on. Okay, the motor locked up, that's good. And I'm going to use the page up, page down. And it works fine. That spins slower than the other axes because this is a Z-axis, and I generally have the motor tuning at a lower velocity. Okay, so we know that the Z-axis works, the X-axis works, and the Y-axis works.